The next concept that we have here is the concept of trains and tunnels. हमने अभी तक जितने भी क्वेश्चंस डिस्कस किए हैं उन सब में वी आर डीलिंग विद पॉइंट ऑब्जेक्ट्स. A point object by definition is an object whose length is negligible or almost zero in comparison to the distance that it travels. So if we have two cars approaching each other from opposite direction, that means दो गाड़ियां opposite direction से एक दूसरे की तरफ आ रही हैं, तो उस केस में हम ये दो point objects के लिए point of meeting define करते हैं. Now, however, consider that we have a train. A train is an elongated object. It's not a point object. Let us say a train is moving past another elongated object, let's say platform. Now, when one elongated object crosses another elongated object, we do not define the point of meeting, rather we define the time of crossing. So, elongated objects के case में instead of dealing with meetings, we instead define the time of crossing. Now, as far as the questions involving trains are concerned, we will be having 4 cases. Let us discuss those cases one by one. The first case that we have here is that of an elongated object crossing a point object. Let us understand this case using a simple example. Let us say that we have got a train and the train is 400 meters long. So, I am considering कि मेरे पास एक 400 मीटर लंबा train है. Now, this 400 meter long train is moving at a speed of 10 meters per second. Also, along with this train, we have got a point object. Now, maybe that's a pole, maybe that's a person who is standing next to the track of the train. We have a point object which is stationary. So, the point object does not move. Now, my question is, how long will it take for this train of length 400 meters to cross this point object? Well, let us understand first of all how the crossing takes place. Can I say that crossing begins when the first part of the train, maybe the engine of the train or maybe the first compartment of the train, reaches in front of the stationary object? Now, the train is moving at 10 meters per second. The crossing will keep taking place until the last part of the train or the last bogie of the train clears of the person who is standing next to the train. So, crossing होने के लिए ये जरूरी है कि क्रॉसिंग तब शुरू हो जब ट्रेन का पहला हिस्सा स्टेशनरी ऑब्जेक्ट के सामने आया है, और क्रॉसिंग तब तक होती रहेगी जब तक ट्रेन का आखिरी हिस्सा या ट्रेन का आखिरी कंपार्टमेंट इस बंदे के आगे से या इस ऑब्जेक्ट के आगे से क्रॉस नहीं कर जाता. ऐसा करते हुए द ट्रेन वुड बी एक्चुअली कवरिंग द डिस्टेंस ऑफ 400 meters which happens to be the length of train itself. So remember, जब भी एक elongated object जो कि मूव कर रहा है किसी स्टेशनरी पॉइंट ऑब्जेक्ट को क्रॉस करता है, तो इस क्रॉसिंग को पूरा करने के लिए ट्रेन को अपना लेंथ ट्रेवल करना है. इस केस में द लेंथ ऑफ द ट्रेन इज 400 meters, सो द ट्रेन हैज टू कवर दिस लेंथ ऑफ 400 meters. नाउ इट इज ओनली द ट्रेन विच इज मूविंग एंड द ट्रेन इज मूविंग एट अ स्पीड ऑफ 10 meters per second. सो कैन आई से ये 400 meters का लेंथ 10 meters per second की स्पीड पे ट्रेवल होगा. देयरफॉर टाइम टेकन टू कवर दिस जर्नी वुड बी 40 seconds. So the train would be crossing this point object in 40 seconds. The concept to understand in case 1 is that when you have a situation where an elongated object is crossing a stationary point object, then the time of crossing is the length of elongated object divided by the speed of elongated object. Hopefully we are able to understand case 1 of the trains and tunnels. Let's move on to the next case now. The second case that we have here is that of an elongated object crossing a moving point object. Let us again understand this case by taking an example. We have an elongated object. Let's say we have got a train and the length of the train has been given to me as 400 meters. So basically मैं पिछले केस को ही further expand कर रहा हूँ. So 400 meters का train है which is moving at a speed of 10 meters per second, and along with this train we have a point object. But unlike case 1, in case 2, the point object is in itself moving, let us say at a speed of 5 meters per second. For the crossing to take place, the length of the train or the length of the elongated object is the distance to be covered. So again, crossing करने के लिए हमें वापस 400 meters का ही distance travel करना है, लेकिन लास्ट टाइम हमने सिर्फ ट्रेन की स्पीड या elongated ऑब्जेक्ट की स्पीड कंसिडर की थी. यहां पे क्योंकि दोनों ऑब्जेक्ट्स मूव कर रहे हैं, हम रिलेटिव स्पीड कंसिडर करेंगे. Now, what is the relative speed if two objects are moving in same direction with speed 10 meters per second and 5 meters per second? Well, that is a difference of 2. So relative speed ends up becoming 10 minus 5, which is nothing but 5 meters per second. So a length of 400 meters is to be traveled at a speed of 5 meters per second. Hence, 80 seconds is the answer. That's second case of trains and tunnels. The third case that we have here is that of an elongated object crossing another stationary elongated object. Let us say that we have got a train and this train is crossing a platform. So train is the moving elongated object and platform is the stationary elongated object. Let me represent that on the board using a diagram. Let us say I've got a train. The length of the train has been given to me as, let's say, 400 meters. तो मेरे पास एक 400 मीटर लंबा ट्रेन है. And this 400 meter long train is moving at a speed of 10 meters per second. Next to this train, we have got a platform. Let's say the length of the platform has been given to me as 1000 meters. So this 400 meter long train has to cross this platform. My question is, how long will it take for this train to cross this platform? Let us understand the situation using props. So let us say the book that I have with me represents the platform that I have. So this length is 1000 meters and the notebook that I have here represents the incoming train. अब क्रॉसिंग शुरू कब होगी? क्रॉसिंग शुरू तब होगी जब ट्रेन का पहला हिस्सा या ट्रेन का इंजन प्लेटफॉर्म के आखिरी हिस्से के आगे आएगा. इस पॉइंट पे क्रॉसिंग शुरू हो गई. सो ट्रेन आगे मूव कर रही है, प्लेटफॉर्म को कवर करती जा रही है और मूव करते 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 इस पॉइंट पे पहुंच गई. अब इस पॉइंट पे ट्रेन का इंजन या ट्रेन का पहला हिस्सा प्लेटफॉर्म के एंड तक आ चुका है. सो बेसिकली इस सिचुएशन से लेकर इस सिचुएशन तक ट्रेन ने टोटल 1000 मीटर्स का डिस्टेंस कवर कर लिया है. लेकिन क्या क्रॉसिंग खत्म हो गई है? नहीं, क्रॉसिंग अभी खत्म नहीं हुई. क्रॉसिंग खत्म करने के लिए जो प्लेटफॉर्म का आखिरी हिस्सा है वो ट्रेन को क्लियर ऑफ करेगा और ट्रेन को क्लियर ऑफ करने के लिए इस पॉइंट से फर्दर 400 मीटर का लेंथ और ट्रेवल करना पड़ेगा. सो बेसिकली व्हाट वी हैव इज अ सिचुएशन जहां पे एक ट्रेन पीछे से आ रही है, वो प्लेटफॉर्म के आगे आते ही क्रॉसिंग शुरू हो जाती है और पहले प्लेटफॉर्म का लेंथ कवर होता है विच इज 1000 मीटर्स और फिर प्लेटफॉर्म का आखिरी हिस्सा ट्रेन को क्लियर ऑफ करता है कवरिंग अनदर 1400 मीटर्स. सो बेसिकली व्हाट वी से इज दैट इन सच सिचुएशंस when we have one elongated object crossing another elongated object, the total distance for crossing to take place is actually the length of two elongated objects combined. So you have to take the length of two elongated objects, add them up, and then that becomes your total distance to be traveled for the crossing to take place. इस केस में ट्रेन का लेंथ 400 मीटर है, प्लेटफॉर्म का लेंथ 1000 मीटर्स है. सो पहले ट्रेन ने प्लेटफॉर्म को क्रॉस किया 1000 मीटर्स और फिर प्लेटफॉर्म के आखिरी हिस्से ने ट्रेन को क्रॉस किया another 400 meters. The total distance to be traveled is 1400 meters. प्लेटफॉर्म तो ऑब्वियसली मूव नहीं करता. इट इज द स्पीड ऑफ द ट्रेन विच इज टू बी नाउ कंसिडर्ड. अगर ये 1400 मीटर को हम 10 मीटर्स पर सेकंड की स्पीड पे ट्रेवल कर रहे हैं तो कैन वी से दैट द टाइम टेकन टू कवर दिस एंटायर जर्नी would be 140 seconds. Hopefully we are able to understand this case. Next we move on to the fourth and last case of trains and tunnels. The fourth case deals with a situation in which we have one elongated object crossing another moving elongated object. Let us say that we have got two trains and the two trains are moving on parallel tracks such that one train overtakes and eventually crosses the other. Let me explain that using an example here on the board. Let us say that the train under consideration is a 400 meter long train. So मेरे पास एक 400 मीटर लंबा ट्रेन है. Now this train is moving at 10 meters per second. Along with this train, we have got another train which is moving on the parallel track. So इस 400 मीटर लंबी ट्रेन के साथ parallel track के ऊपर एक और ट्रेन मूव कर रही है and the length of the train is 500 meters. तो इस ट्रेन के पैरेलल ट्रैक पे एक और ट्रेन मूव कर रही है, 500 मीटर लंबी ट्रेन मूव कर रही है विच इज मूविंग एट अ स्पीड ऑफ 5 meters per second. So we have a situation in which this elongated object is crossing the second elongated object. अब अगर हमें थर्ड केस का डिस्कशन क्लियर हुआ है, तो फ्रॉम देयर आई कैन डायरेक्टली से दैट द टोटल डिस्टेंस टू बी ट्रेवल्ड विल बी द सम ऑफ टू लेंथ्स. So the total distance to be traveled for this crossing to take place will be 400 plus 500, 900 meters. Now this length of 900 meters is to be covered with a relative speed of 10 minus 5 meters per second. So we cover this length of 500 meters with a relative speed of 5 meters per second. The final answer ends up becoming 180 seconds. So it will take 180 seconds for 400 meter long train to cross the other train which is 500 meter long. Another situation that we can have is the two trains, instead of moving in the same direction, are moving towards each other. So same direction में जाने के बजाय दो trains एक दूसरे के तरफ move कर रही हैं. Does not matter, the total distance to be traveled for the crossing to take place will still remain 900 meters. The only thing that will change is the relative speed. So पिछली बार relative speed 10 minus 5 meters per second था, अब relative speed 10 plus 5 15 meters per second हो जाएगा, and our answer would be 60 seconds. With this we end our basic theoretical discussion of trains and tunnels. Let's move on to examples now. A train travels at a speed of 72 kilometers per hour. It passes a signal pole in 23 seconds. Find the length of the train. In this question, the condition that we have is of an elongated moving object crossing a stationary point object. So this is very similar to the case 1 of trains and tunnels that we have already discussed. What we are supposed to find here is the length of the train. Let us begin the question by assuming the length of the train. So I am assuming the length of the train to be x. So this train, which is x meters long and is traveling at 72 kilometers per hour, takes 23 seconds to cross a signal pole. So ये एक moving elongated object इस stationary point object को 72 की speed के साथ क्रॉस करने में 23 seconds लगाता है. That is what is given to me in the question. अब अगर हमें केस 1 ऑफ ट्रेन्स एंड टनल्स याद है, तो वहां पे हमने जो कंसेप्ट डेवलप किया था दैट वाज कि अगर हमें एक एलोंगेटेड ऑब्जेक्ट का पॉइंट ऑब्जेक्ट के साथ क्रॉसिंग का टाइम निकालना है, देन टाइम ऑफ क्रॉसिंग वुड बी गिवन एज द लेंथ ऑफ एलोंगेटेड ऑब्जेक्ट डिवाइडेड बाय द स्पीड ऑफ एलोंगेटेड ऑब्जेक्ट. सिंस यहाँ पे मेरा टाइम सेकंड्स में है, आई नीड टू कन्वर्ट द स्पीड ऑफ किलोमीटर्स पर आवर इनटू मीटर्स पर सेकंड. सो 72 into 5/18 gets me 20 meters per second as the speed of the train. So the train would be covering its own length, which is x meters, at a speed of 20 meters per second, and the time that it should take is 23 seconds. From here I can get the value of x as 23 into 20, 460 meters. So length of the train at hand is 460 meters. Hopefully that was a very easy example for us to understand. Let's move on to the second example now. A train of length 200 meters crosses a tunnel of length 520 meters at a speed of 54 kilometers per hour. How long will it take to completely cross the tunnel? In this question, the situation that we have is of a moving elongated object crossing a stationary elongated object. So this is very similar to the third case of trains and tunnels that we have already discussed. Let me represent the entire question in the form of a diagram. So this is the tunnel that we have, and as per my question, the length of this tunnel has been given to me as 520 meters. A train which is moving at 54 kilometers per hour is crossing this tunnel, and the length of this train has been given to us as 200 meters. If we have already understood the third case of trains and tunnels, then from this much of data I can directly say that for the crossing to take place, the total distance to be traveled will be the sum of two lengths. So क्रॉसिंग करने के लिए जो टोटल डिस्टेंस ट्रेवल करना है वो ये दो लेंथ्स का सम है. सो कैन आई से टोटल डिस्टेंस टू बी ट्रेवल्ड इज 200 plus 520, a total of 720 meters. The train has to cross a total of 720 meters to complete this crossing. Also, the train will be covering this distance of 720 meters at a speed of 54 kilometers per hour. By the way, मैं meters को kilometers per hour की speed के साथ divide नहीं कर सकता. So first of all, I need to convert the speed of 54 kilometers per hour into meters per second. For that, I multiply 54 with 5/18. When 54 gets multiplied with 5/18, the speed of the train ends up becoming 15 meters per second. So now the situation that we have is A distance of 720 meters is to be traveled at a speed of 15 meters per second. Therefore, the time of crossing will be given as 720 by 15. सबसे पहले इसका 3 के साथ कटिंग कर लेते हैं. This is 3 5s are and this is 2 and 4 240. Now 240 divided by 5 gets us 48 seconds as the answer. So the train will take 48 seconds to completely cross this tunnel. Let's move on to next example now. A train crosses a pole in 6 seconds and a 100-meter long platform in 14 seconds. Find the speed and length of the train. Most of the questions that we get on trains and tunnels are directly one of the 4 cases of the trains and tunnels that we have discussed. But sometimes we do encounter questions जहाँ पे एक से ज़्यादा cases को combine करके question बनाया जाता है. This is that one particular question type. यहाँ पे एक train एक स्टेशनरी ऑब्जेक्ट को, एक स्टेशनरी पॉइंट ऑब्जेक्ट को भी क्रॉस कर रही है और एक स्टेशनरी एलोंगेटेड ऑब्जेक्ट को भी क्रॉस कर रही है. सो वी हैव टू सॉल्व सच क्वेश्चंस बाय क्रिएटिंग टू डिफरेंट केसेस. For the first case of the question, it is given to me that a train crosses a stationary point object, which is basically a pole, in 6 seconds. Now, what is the length of the train? That I don't know. What is the speed of the train? Even that I don't know. So I begin the question by assuming the length of the train to be x and the speed of the train to be s. So एक x meters लंबी train traveling at a speed of s meters per second is covering a signal pole, or it is crossing a signal pole in a total of 6 seconds. This situation that you have here is the case 1 of trains and tunnels. हमने केस 1 में समझा था कि जब एक elongated moving object एक stationary point object को क्रॉस करता है तो उस केस में time of the crossing is defined as length of the elongated object divided by the speed of elongated object. This time is given to me as 6 seconds. So in a way, x by s has been given to me as 6, or perhaps from here I can say that x is equals to 6s. Also, there's a second part of the question. In the second part of the question, the same train is crossing a 100-meter long platform. So हमारे पास एक x meters लंबी ट्रेन है जो अब एक पॉइंट ऑब्जेक्ट को क्रॉस करने के बजाय एक प्लेटफॉर्म को क्रॉस कर रही है. So let us say that the length of the train is x, the length of the platform is 100 meters. So now this train has to cross this platform with a speed of s meters per second. This is the third case of trains and tunnels, and we have already learned in the third case of trains and tunnels that in such a situation the time of crossing is determined by the length of two objects. So crossing करने के लिए जो total distance हमने travel करना है, that will be the length of two objects added. So total distance to be traveled is x plus 100 meters. Now this distance of x plus 100 meters is to be traveled at a speed of s seconds for the time of crossing to be calculated. हमने अगर टाइम ऑफ क्रॉसिंग को कैलकुलेट करना है तो हमने x plus 100 meters के डिस्टेंस को s meters per second पे ट्रेवल करना है. As per my question, this time has been given to me as 14 seconds. Now I can simplify this expression to get an equation. So x plus 100 equals 14s. Also, I have learned that x is defined as 6s. हमने केस 1 में से डिटरमिन किया था that x is equal to 6s. So अगर x 6s है तो मैं उसे यहाँ पे सब्स्टिट्यूट कर सकता हूँ. 6s plus 100 is equals to 14s. From here I can say that the value of 100 ends up becoming 8s. And if 8s is 100, from there I can say that the speed of the train is 25 by 2, or perhaps 12.5 meters per second. My question wanted me to find two things. Number one, the speed of the train, that I found out to be 12.5 meters per second. The second thing that we were required to find was actually the distance or the length of the train. Well, I can determine that using the expression x is equals to 6s. If s is equals to 12.5, then the length of the train x can be determined as 6 times 12.5. By the way, I can write this 12.5 as 25 by 2. So x is equals to 6 into 25 by 2. That gets you a 3. So x ends up becoming 75 meters. The length of the train to be covered is 75 meters. The length of the train is 75 meters. In this question, we were required to determine two things. Number one, the speed of the train. Well, that is 12.5 meters per second. Number two, the length of the train. Well, that is 75 meters per second. Hopefully we are able to understand this example. You will come across many such examples जहाँ पे दो cases को combine करके question बनाया गया है. Let's move on to another such example. A train is running at 54 kilometers per hour and takes 20 seconds to cross a platform and 12 seconds to pass a man walking in the same direction at a speed of 6 kilometers per hour. Find the length of the train and that of the platform. In this question, we have a train which is crossing a platform as well as a moving point object. Now, we do not have the length of the train nor we have the length of the platform. So I begin the question by assuming the length of the train to be x and that of the platform to be y. So here we have a train of length x moving at 54 kilometers per hour, crossing a platform which is y meters long. So what we have here is a moving elongated object crossing a stationary elongated object. This is the third case of your trains and tunnels. In such a case, the total distance to be traveled for the crossing to take place is the sum of two lengths. So first of all, I say that a distance of x plus y meters is to be traveled if this crossing has to take place. Next, my question also says that the time taken for this crossing to take place is 20 seconds. Now, if the time taken is 20 seconds and I have to define the time of crossing, we know that time of crossing is distance by the speed. So, if we have to define the time of crossing, that will be a distance of x plus y traveled at a speed of 54 kilometers per hour. Since I am assuming the length of train as well as that of platform in meters, I cannot divide this length with a speed which is in kilometers per hour. So I convert this 54 kilometers per hour into meters per second by multiplying that with 5 by 18. So 54 into 5 by 18 gets me 15 meters per second. So the speed of train is effectively 15 meters per second. Now a distance of x plus y is traveled at a speed of 15 meters per second and the time taken is given to me as 20 seconds. From this expression, I get the value of x plus y as 20 into 15, 300. So the length of the train plus length of platform combined added together is 300 meters. This was half the question. In the second case or in the second half of the question, we have the same train. So obviously a train of length x moving at the same speed, which is 54 kilometers per hour. So we have the same train crossing a man walking in the same direction at 6 kilometers per hour. So now what we have is the case 2 of trains and tunnels. An elongated object crosses a moving point object. In such a scenario, we end up applying relative speed. So first of all, let us calculate the relative speed of two objects moving in same direction. Well, for two objects moving in same direction, the relative speed is the difference of two speeds. So that is 54 minus 6 or perhaps 48 kilometers per hour. Since the time of crossing has been given to me in seconds and I'm supposing the length of the train in meters, it would be better to convert this relative speed of 48 kilometers per hour into meters per second. For that, I consider my 48 and I multiply that with 5 by 18. So this is 6 3s are, this is 6 8s are, so 8 into 5 is 40. The relative speed ends up becoming 40 by 3 meters per second. For the crossing to take place, this length x is to be traveled with this speed. So can I say the time of crossing is a length of x traveled with the speed of 40 by 3 meters per second. Now this time has been given to me as 12 seconds. From this expression, I can take 40 by 3 and multiply it with 12 to get the value of x as 12 into 40 by 3 or perhaps 160 meters. Now what was my x? X was the length of the train. So from here I can deduce that the length of the train is 160 meters. If the length of the train is 160 meters, the value of x is 160 meters and x plus y equals 300. From here I can find the value of y, which is 140 meters. Y was the length of the platform. So the length of the train is 160 meters and the length of the platform is 140 meters. Hopefully that's an easy question. Sometimes on your trains and tunnels, we might get questions which are little bit lengthy. ये थोड़ा सा lengthy जरूर है, but it is a doable question. We can easily do it. Let's move on to the next example now. A faster train crosses a slower train in 25 seconds when they are moving in the same direction, whereas it would have taken only 7 seconds to cross if they were moving towards each other. Find the ratio of the speed of two trains. In this question, what we have is a situation where two trains, if moving towards each other, cross each other in 7 seconds, while if moving in the same direction, then they take 25 seconds to cross each other. इस क्वेश्चन में जो चीज मुझे नहीं गिवन है वो है लेंथ ऑफ द ट्रेन्स और ना ही मुझे स्पीड ऑफ द ट्रेन्स गिवन है और मुझे यहाँ पे स्पीड ऑफ ट्रेन्स का रेशियो निकालना है. मैं सवाल को शुरू कर सकता हूं by assuming the length of the trains as x and y. So I begin the question by assuming the length of the trains as x and y. Let us say x is the length of the faster train moving at, let's say, speed s1, and y is the length of the slower train, let us say, moving at speed s2. Since ये वाला ट्रेन इसके कंपैरिजन में फास्टर ट्रेन है, so what I say here is s1 is greater than s2. If these two trains are moving in same direction, if they are going in the same direction, then for the crossing to take place, I would be considering relative speed. The distance to be covered for this crossing to take place will be the sum of two lengths. So if the distance to be covered is x plus y and this distance is to be covered with a relative speed of s1 minus s2, then this fraction should give me the time taken and this value has been given to me as 25 seconds. अगर वो सेम डायरेक्शन में जा रहे हैं तो उनको x प्लस वाई का लेंथ s1 माइनस s2 की रिलेटिव स्पीड के साथ कवर करना है और ये टाइम 25 सेकंड्स मुझे गिवन है. सेकेंड केस में these two trains are moving towards each other. So the faster train and the slower train is now moving towards each other. If two objects are moving towards each other, the relative speed ends up becoming the sum of the individual speeds. So can I say अगर last case में relative speed s1 minus s2 थी, तो इस case में relative speed will end up becoming s1 plus s2. Distance by speed shall give me the time taken of crossing, which is given to me as 7 seconds. Now, from these two expressions, I can create equations in x, y, s1 and s2 and solve those. Let us consider this expression. Can I say अगर मैं s1 s2 को इधर जाकर मल्टीप्लाई कर दूं तो इक्वेशन वुड लुक ऑफ द फॉर्म x plus y equals 25 into s1 minus 25 into s2. In a similar way, I can derive another equation from this expression. So x plus y equals 7s1 plus 7s2. Now, since left hand side of the first equation is x plus y and the left hand side of the second equation is also x plus y, I can equate these two equations. So the equation that I now get is 25s1 minus 25s2 is equals to 7s1 plus 7s2. Let us take all the all the values of s1 on one side. So 25 s1 इधर है, 7 s1 इधर है. So 7 s1 को लेफ्ट साइड पे मूव कर लेते हैं. So what do we get here? 25 minus 7 s1, that is 18 s1. Let us move all the values of variable s2 onto the other side. So यहाँ पे minus 25 s2 है, उधर जाकर ये add हो जाएगा. So what we are going to get here is 32 s2. From here, can I say that the ratio of speeds s1 and s2 is nothing but 32 is to 18 or perhaps 16 is to 9? Hopefully, we are able to follow this example. Now, this is a standard example that you often see on your paper. Next, we move on to an example जहाँ पे हम speeds की ratio के बजाय length of the trains का ratio निकालेंगे. Two distinct trains take 8 and 12 seconds respectively to cross a signal pole. To cross each other when traveling towards each other, they take 10 seconds. Find the ratio of the length of the two trains. In this question, what we are given is that we have two trains, obviously of different lengths, traveling at certain speeds and taking 8 seconds and 12 seconds to cross a signal pole. Neither I am given the length of the trains nor I am given the speeds of the trains. So if I have to begin the question, the starting point should be the supposition of the lengths as well as the speeds. हमारे पास दो ट्रेन थी, मैंने पहली ट्रेन की लेंथ को x मान लिया और उसकी स्पीड को s1 मान लिया. Now, x by s1 should give me the time taken by this train to cross a signal pole. X represents the length of the train, s1 represents the speed of the train. Now, x by s1 is length of the train by the speed of the train. This ratio gives us the time taken by the train to cross a signal pole or a point object. So for the first train, x by s1 is 8 seconds. In a similar fashion, I can assume the length of the second train to be y and its speed to be s2, so that y by s2 gives me the time taken by this train to cross a signal pole, which is 12 seconds. Also, I am given that these two trains while moving towards each other cross each other in 10 seconds. By the way, अगर दो trains, दो elongated objects एक दूसरे की तरफ move करते हुए एक दूसरे को cross करते हैं, in that case, the distance to be traveled is x plus y, and obviously this distance is to be traveled with the relative speed. Since they are moving towards each other, relative speed ends up becoming s1 plus s2. So length of the two trains combined divided by their relative speed shall give me the time of crossing, which has been given to me as 10 seconds. Now I can further simplify this expression. So x plus y equals 10s1 plus 10s2. Now from this expression I am required to find the ratio of the length of the two trains. तो मुझे यहाँ से किसी तरीके से x और y का रेशियो निकालना है. What I do not require in this equation is actually the variable s1 and variable s2. Now, can I use this expression and this expression to substitute variable s1 and s2? Yes, I can. If x by s1 equals 8, from here I can say that s1 will be nothing but x by 8. And in a similar way, if y by s2 is equals to 12, from here I can say that s2 will be nothing but y by 12. Now I can take this value s1 and this value s2 and substitute them into this equation. So x plus y equals 10s1. What was s1? X by 8. So 10 times x by 8 plus 10 times s2. What is s2? Y by 12. So 10 times y by 12. Let us simplify this. 2 से cutting कर लेते हैं. This is 5 and 4 and this is 5 and 6. Furthermore, denominator में 4 and 6 है, तो I multiply the entire equation with 12. Now what do I get? 12x plus 12y equals, okay, अगर मैं 5 by 4 of x को 12 से multiply कर रहा हूँ, that will end up getting me 15x. And अगर मैं 5 by 6 of y को 12 से multiply कर रहा हूँ, that will end up getting me 10y. So 12x plus 12y equals 15x plus 10y. x के सारे टर्म्स को एक साइड पे कर लेते हैं. सो 12x उधर जाकर माइनस हो जाएगा. व्हाट डू आई गेट हियर इज 3x. 10y इधर आकर माइनस हो जाएगा. सो व्हाट डू आई गेट ऑन द लेफ्ट साइड इज 2y. नाउ आई वाज रिक्वायर्ड टू फाइंड द रेशियो ऑफ x by y. द रेशियो ऑफ x by y ends up becoming 2:3. So the ratio of the length of the two trains is 2:3. With this example, we complete with the chapter of trains and tunnels. With this, we are also ending the third lecture of time, speed and distance.